This is the ROS Developers Podcast, episode 89.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all those roboticists out there that are considering about using ROS in their robots. So I'm basically dedicating this podcast episode to the mechanical engineers out there that they are building the robots and they are hearing about ROS. So what is this ROS? What is why it is related to robotics? Should I have a look at it? Then if that is the case, this episode is dedicated to you. And why I'm dedicating this episode there? Well, the reason is because this podcast is actually an interview that was made to myself. And it was it's an interview made by a roboticist, Dr. Sina Purgodrat. And Sina is a surgical robotics software engineer. And he has a very interesting channel in YouTube that I'm going to include the link into the show notes so you can visit and subscribe to his channel, of course. And in this channel, he is talking about robotics and how to become a roboticist and what's the path that you have to follow, etc. But they don't talk much about ROS. So then Sina proposed me, hey, that would be interesting for our channel if you can come to the channel and then do an interview so you can explain what is ROS, why it is important, why people should learn ROS if they are building robots. Then that was the interview that he made to me, and then I'm going to include this interview here in the podcast. So this podcast is basically showing this interview. Then without further ado, then let's go with the interview made by Sina to Ricardo. Let's go.
All right, so our guest today is Ricardo Teles from Barcelona, Spain. He's a ROS expert. He's the CEO and founder of The Construct, an online platform for learning ROS and robotics. He has a PhD in AI, and he's the author of 4 books on ROS. Ricardo, thank you very much for joining us today.
My pleasure. I was just pointing to the things that you were saying about me. So I just using the opportunity to point to the things. Thank you, Sina. Thank you. My pleasure.
Sure. Yeah, so Ricardo, tell us a little bit about your journey going from AI to robotics and to ROS.
Okay, so I always wanted to work on AI since I was a child. And then I started studying engineering and so on. But when I reached the university, at that time, it was the 90s, late 90s. And then the only robots that were there were the arm robots, that were doing mechanical things all the time, same things, no perception, no intelligence. And I was so deceived of that, and I said, wow, that's not what I was thinking about. And then as I finished my career and started to work on other engineering jobs, until one day that I went to a conference. One friend sent me that invitation. Hey, you must go to this conference. So I went there. It was here in Barcelona, where I am located. And there was this researcher on artificial intelligence who his name is Luke Steels, and he was the director of the Sony AI lab in Paris. So Sony had 2 AI labs, and one was in Japan, and the other one was in Paris, in France. And then he was delivering this conference, and he came to the conference and started to talk about that robot over there, AIBO robot.
Oh, that's an IBO. Yes, I know that
Yes.
robot.
Yeah, the AIBO robot, it's amazing. It's a robot dog. And then it can walk and it can interact with the person. And that was about the 2000 and something, 2002, 2003, something like that. And I said, wow, that's it. That's what I wanted to do. Exactly those things. For me, those are robotics. For me, the other are just machines. But robotics is this. So that's what I want to build. The robots of the movies. Then is when then I decided, I went to, when he finishes, I went and said, hey, what do I have to do to work with you on this? What do I have to do? And he says, so do you have a PhD? I say, no. Okay, then you have to go for that. Okay, okay. Then when you have done it, come and contact me. And then that's what I did. Then I quit my job and I went to do this PhD. And I was obsessed about working at Sony for developing those robots. But when I was about to finish my PhD, I found a company here in Barcelona who is called PAL Robotics. And it's a company that develops humanoid robots, but human-sized humanoid robots. And then I say, oh, I have to see what you are doing. So I contact the director. I say, hey, I'm not looking for a job. I just want to see what you are doing. Please, you have to allow me to visit you and show me what you are doing. And the guy who he was the boss at that time is Davide Faconti, who is very famous, very well known in the ROS world. And then at that time, ROS didn't exist at that time. And then he was saying, oh, yeah, come, I will show you. And then he showed me the robots and so on. And I was making a lot of questions. And when I left on the next day, they told me, hey, if you want, we have a job for you. I say, no way, yes, okay. I say yes. And then I started to work. Before finishing my PhD, it was about just the final part of the PhD. You know, the part, the most boring part when you had to write and finish the writing. So I was on that time, and then I said, okay, yeah, let's start working. And I started working there and finished my PhD and was working there for more than 7 years on that company. Yes, and then at that company is where it was amazing. I enjoy it very much. There is where I learned ROS. We put ROS on those humanoid robots. And yeah, basically until I left the company and built my own, which is the construct, which is about learning how to program robots with ROS. And here we are.
Okay, perfect. Thank you very much. Yeah, so you just explained that, and I know from reviewing your sites and everything that you're an expert in ROS. So can you tell us in simple words, what is ROS?
Yes, that's a very good question because it's not clear for the newcomers. So they don't know. So, but what is ROS? Because ROS stands for Robot Operating System, but it is not an operating system. It's actually a framework that is put on top of the operating system. So you install in any robot, you have a computer. And then let's say it's a Linux machine because it's a big robot. Well, I have another one over there. I don't think that you can see that. But even wheeled robots, they have a computer, even if it's small. Then you install Linux there, like a normal PC desktop computer. And then you install ROS as a set of packages that you are adding to the Linux system. They are just a set of packages. Then by installing this, you can create ROS-enabled programs. And you will say, yeah, okay, so ROS-enabled programs like, I don't know, remote control enabled programs. So why do I care about that? Well, so ROS is has revolutionized the field of programming robots, because by having this framework, you can program, you can create programs for robots based on that framework. So actually, at the end, you are programming for ROS, not for robots specifically. And what that implies is that you can create programs that can be shared between different robots. So before ROS, if you have a robot with 2 wheels and you wanted to move it around a room, then you had to create a program for this robot. And then you buy another robot, a different robot with 4 wheels. And then you have to create another different program for that robot also. So you cannot reuse the one that you created for the first one. You have to create again. If you want to apply this program to a copter, a drone, again, you have to create again another program. That's before ROS. But if you use ROS, you install ROS on all those 3 robots, and then you only need one single program. The same program will work on on all 3 robots, and you just need to change a few things of configuration files, just a little bit. But then that allows us to share programs. So I can create a program myself and send it to you, or put it on the Git. And then you, at your home with your own robot, you will be able to use the same program. So now everyone can share robotics programs in the same way that we are sharing programs for Windows, for example. You know, so you have a different computer than me, but I have Windows, you have Windows, then you can send me a Windows program and it will execute in my computer, more or less the same as in yours. So the same is applied for robots. If you put ROS, then you're allowed to share programs. And by doing this, we are speeding development of programs for robots, because we don't have to be reinventing the wheel all the time.
I see. So you basically make the code reusable, and it's similar to Linux virtualization, right? So
yes,
you program it once, and then you create basically a platform, a virtualization platform that you can copy for different systems, different platforms.
Yes. Well, it's nothing related to virtualization. Is the concept of virtualization. It shares the concept of sharing the programs, or executing the same program, but the concept is nothing related to virtualization. ROS doesn't use any virtualization. It's something different. It's something different. I don't want to get into those details, how it works in the inside, because for newies that's very complicated to understand at the beginning. Then it's better to explain with an example, with a table. So, but you have to understand the concept that by using a program that has been made for ROS, that makes your software shareable between different robots, even if they are different. You know, instead 2 wheels, okay, 4 wheels, yeah, the same. Even a drone, even a underwater robot vehicle, you can use most of the software that has been already made for land robots.
How about some of the libraries that are available in ROS? For example, let's say I'm trying to program a robot arm, and I need like a robotics kinematics library. Is that also available in ROS? Can I just do I have to like so if I'm not programming inside ROS, then I have probably to develop everything from scratch, all of those rotation metrics and everything.
Exactly.
But if I have ROS, it's already there, the library is already there, I can just easily use it, right?
Correct. Exactly that you nail it. You put into the point. And let me give you an example before going to the arm movement, kinematic, arm kinematics, and so on. A very typical application for a robot, for a service robot, for an autonomous robot. That's for me a robot. Okay, something that behaves by itself. So it has to be able to navigate. Navigate means move by itself wherever you say. So, for example, go to the kitchen. Then the robot has to know how to drive the path to the kitchen and avoid the obstacles. If there is a person in the middle, then it has to avoid it. And then if you come back to the main room, then it has to come back, know how to come back, right? This is basic skill in an autonomous robot. So
Right.
this is already done. The algorithms for this, the SLAM algorithms for creating maps, the Kalman filters for doing localization of a robot, the path planning algorithms, all that is being already made in ROS. So you can buy a robot now, even if with little knowledge, you can buy a robot now. Well, and if you know ROS, in half an hour, you have this robot moving around your home.
I see. So
because you download the package. Sorry.
Yeah. So that's the key feature that ROS provides. It has a lot of built-in libraries that you can just pick or use and integrate it into your workflow, into your robotics workflow.
Exactly. And this is possible because of what I mentioned about the layer of ROS that is kind of a standard that allows to share the programs. Because before ROS, we had to create, as you mentioned before, the kinematics library for every arm that we were putting on our robots, on the humanoid robots. When I was developing there, it didn't exist, ROS. And then we had to, and for this robot, okay, the arms are like this size and this length and I don't know, this number of joints. Then you had to type all the library and see many errors. Debugging that was horrible. And then you change another robot and then you have this problem again. You had to do it again. Now it's available. There is a package which is called the Move It. It's a series of packages that provide you with the kinematics for robot arms. So you don't have to do nothing. You have your arm like that one that you have there. Then you have to create what it's called the URDF model of the robot, which is the 3D model of the robot. So how many parts, where there is a join. It's like a CAD model. It's the same, but format is called URDF. And then you provide this to the Move It, and that's it. In a few minutes, you have your robot grasping things, moving there, and you don't have to create any program for that.
That's right. Cool. Awesome. Now, let's say my next question is who should learn ROS? Let's say I want to become a robotics mechanical engineer where I will design robots and maybe like come up with the idea, prototype it, 3D model it, prototype it. Should I learn ROS as well, or learning ROS will be more for people who want to become a robot programmer or robotics developer or robotics software engineer?
Exactly. It's the second case. So if you are going to be focused on the mechanical parts or even the electronic parts of the robot, then you don't need to learn ROS, because ROS is more for building the behaviors of the robots. So you can build a robot, very sophisticated robot, but if you don't put the proper software on top, then that robot does nothing useful. You can do nothing. So even if you build a very good robot, physical robot, then you need to put the software. So for the software that allows you to interact with the robot, to ask him for doing things, command the robot, and the robot to decide by itself what to do now, how to avoid the obstacles, how to recognize this, then in that case, if you want to dedicate to that part, which is more, we call a ROS developer. So you want to become a ROS developer who is a person who develops software for ROS robots.
I see.
In that case, you have to learn ROS.
I see. Okay, so now that we know what ROS is, can you tell us how popular ROS is in the industry and maybe name some robotics companies who use ROS?
Yes, in that case, okay. So, what about if I say NASA as a company that is using ROS? Last week, there were two big news about NASA. The first one that probably everybody knows, which is that they land the rover in Mars. Another one, but more sophisticated. It was amazing. I was watching that live. Did you have the chance to watch it live, Sina?
Yep. Yeah, I did watch it.
Amazing,
Yes.
amazing, amazing. Even if I like more the transmissions of SpaceX, they are more entertaining and very better done. I think the SpaceX transmissions when they launch something. But anyway, that was a feat of the humanity sending that rover there. Okay, so that was the first new. Second new is that they announced in a different channel, they announced that they are putting ROS 2 on the next rover that they are going to send to the moon. That's that. So that's a way of saying how mature and how important is becoming ROS in the robotics world. It's so important that they are putting this in a critical machine. So far, the NASA has been using ROS as a way of prototyping, but nothing for the end thing that they are sending to the planets or sending to the space. They also have had a couple of robots in the International Space Station, but those robots were not so they were just doing tests of how those robots will behave, but they were doing nothing important, nothing that is critical, nothing, just trying and so on. But this is the first time that they are using ROS2 for something critical. I mean, is the mission of the robot itself when it is behaving on the land, on the moon, inside the moon. So that's the case. By the way, they have put an employment offer on internet looking for a ROS specialist to work on at NASA for that project. So if anybody's interested, you can Google it. So that's
Awesome.
so important is becoming the ROS. I think that it's going to become the standard for any robot. Still is not, but it's becoming and yeah. So I don't see any other possible option that is going to take the lead that ROS is taking. I don't
I
see.
see. So you're saying ROS is growing in popularity, and more companies and
Yes.
organizations are using it now, right?
Yes, exactly. Correct.
Okay. And then you said, my impression was when I started learning about ROS, I thought ROS is only used to program robot arms. But as you explained, ROS is used almost for any type of robots.
Yes, correct. Exactly. Even so, actually, armed robots were later because the people who developed ROS, they are more like me in the sense that when we think about robots, we think about machines that are moving by themselves and deciding what to do on the next step, not doing something, or a robot with wheels that is moving like this and then like this and like this, or you know those robots of that we can see on Amazon that they go following some lines and they go under the shelves, then they put
Oh, I
it.
see the warehouse robots.
Yeah, those warehouse robots, so on. So at the end, for me, those are machines also because they have a fixed plan. Okay, so it's like this, then this, and this, and then this, and then so that's a fixed. This is, let's say, this is not autonomous. Even if there is nobody commanding, there is something that is fixed. Nothing bad can happen that they have to react to. Then instead, the creators of ROS, they were thinking about what we call service robots. And service robots are robots that have to work with humans, beside humans, or in an environment that is for humans and that can be humans around. And when you have humans around, then the unexpected can happen. So you have to have some kind of a skill for dealing with those unexpected situations. And
Right.
that's why they apply first ROS to these kind of robots. And then as it grow popularity, they start to say, oh, but industrial robots are the real robots that are doing, so you can find a business. So the other robots, they are just like crazy ideas of engineers, you know, because nobody's selling robots that are autonomous because they
Right.
lack
Right.
any functionality. But the industrial robots, they are already working on the factories. There are a lot of robots there, and there is a big problem that you cannot share programs between them because everyone has its own manufacturer's operating system and coding system. So they say, oh, wait a second. We can go there, provide ROS, and then we can make business. So people involved in ROS can make business because they will be selling programs and robot based on ROS and so on. And also we'll be able to get in industrial robots out from these kind of regions or for each manufacturer, you know, that you cannot share anything and then you depend on that company for everything. Okay, so they started to do that. Of course, the companies, they start to oppose and so on, but they are winning the terrain. There is a consortium called the ROS Industrial Consortium, which is dedicated to show the companies, hey, that's good for you. If you have this system in your robots, yeah, you are going to lose your so this space that was only for you. But on the other side, you have so much amount here of software that we have developed and many developers have developed, and you don't have to create, you don't have to maintain, and you can provide that
Right.
with your robots. If you need somebody to develop for your robot, you can hire a lot of ROS developers that out there. So those are those advantages. And
Yeah. You don't
so
have
they
to
are,
reinvent the wheel, right?
yeah, exactly, for each
Yeah.
new robot.
Yeah. Okay, cool. Okay, so Ricardo, you talked about the opportunities, job opportunities for ROS developers.
Mhm.
Can you elaborate a little more? Tell us about like how high is the demand for ROS developers, and maybe give us some examples of job opportunities in Europe and in the United States and maybe Canada.
Okay, so at present, the demand for ROS developers is not so high as in other type of robotics engineers, and it is definitely increasing a lot. And I cannot tell you by countries. I cannot tell you. I think in the States is where there are most of this. In Europe also there are a lot. What I can tell you is at any conference that I go about ROS, there is a main conference which is called the ROS Con, which is the official yearly conference of ROS. And then all the companies, we go there and we present our products, and then the people present their papers and experiment. And there is a lot. It's very cool. So I recommend you to attend if you are interested in ROS. But the important thing is that all the companies there, they were showing a big sign saying, hey, we are hiring. Those are companies based on ROS. Their products are based on ROS. Like, I don't know, famous companies on this sector. Well, as I mentioned, SPAL Robotics is one of them. Then there is ClearPath, which is a Canadian company. Fetch Robotics, also very famous. Actually, the CEO of that company was one of the creators of ROS herself. And then also, so they are always there looking for new people, and well, and many others. So what I recommend to the audience, to your audience, is that they subscribe to one email list, which is called Robotics Worldwide. You can search that on Google, and then you will see robotics worldwide email list. And then they subscribe, you will be starting to receive positions from around the world. So the people is looking for, I don't know, an engineer for this, or even for doing PhDs, doing postdocs, for working in companies, for doing consultancy, all that. So what I recommend is that your audience subscribe and then checks there when they are requesting for ROS jobs. You will see that there are a lot that are requesting ROS. But the thing is that this is increasing because ROS is becoming more and more mature. Now, at present, there exists another version of ROS, which is called ROS 2. And this is the one that is becoming the one more adopted by the companies. Well, it's becoming. I mean, it's starting slow yet. So the most used for products at present is ROS 1 yet, is ROS 1. But the problem in ROS 1 is that it was thought for research, for universities, for testing this concept, but it was not tested for the robustness required in most of the robotics applications in the real world that are dangerous. For example, inside an autonomous car. So there are several companies doing autonomous cars that they are using ROS 2. And there is one company, it's called Apex AI, which is a States company, a United States company that is dedicated to certify this ROS 2 for autonomous cars. So you can put your ROS 2 on the autonomous car and be certified, and then use all the software that already exists. There are lots of packages for making your car autonomous if it works with ROS. And it's already done. So you can just put it there and tune it a little bit for your specific. So the situation is that it's growing, and I can tell you that I can feel this growing interest in more ROS developers and more ROS developers. And the good moment is now, because it's like when data science, you know, data science, so there were just a few guys doing data science 15 years ago, just a few guys. Now everybody everyone is a data scientist. You do like that. You look beneath the table and there are 10 guys doing data science there. What are you doing there? So there's too much competition. Now you can become a ROS expert now, and the competition is not so big. But you had to take this risk.
Seriously,
because
now.
Yeah, it has to be now, exactly.
Yeah. So you just mentioned data science. So why someone should become a robotics engineer or ROS developer as opposed to, let's say, a web developer or a data scientist?
Okay. Yes. So that's a very good question. And I think that nobody should. Nobody should. I don't believe, and I don't believe, I completely reject this idea that, hey, there is a possibility of jobs there. So let's go there and let's learn whatever it is, this and this, or I'm going to become this because there is a possibility of a job. I don't believe that. It's a life opinion, okay? So it's a personal opinion. I respect other people, but so I think that you have to do what you feel that is the thing that is going to motivate you, that when you have to work on that subject, then you feel like, wow, I want to stay here more. I want to continue doing this. But yeah, but it's already 9 in the afternoon. So yeah, okay, let's have some lunch and let's continue. So this kind of passion is what I
Right,
believe
something
in.
that you enjoy.
Yeah,
something that I enjoy, and it doesn't feel like work. It feels like you really like it and you do it because you enjoy doing it.
Yeah, my boss, when I was at PAL Robotics, the one that hired me, when I asked him, hey, Davide Faconti. So we were talking one day, and so we're eating during lunchtime, and somebody asked, and what would you do if you win the lottery and then you win 100 millions? And then I know perfectly my answer, but it was Davide who said it. And they said, yeah, well, the next day, what I would do, build robots. I'm going to do the same thing I'm doing, maybe with more resources, maybe better equipped, or maybe not, because maybe it's not necessary to have, but I will do the same thing because that's what I love. So if you love to program robots, then you should learn ROS. That's different. But only if you love to program robots. If you don't like it, then don't do it. There is a lot of work on developing the hardware of the robots, because the robot is a composition of three things, right? The mechanical part, the electrical part, the electronics part, and the software part. So and if you love robots, then you can apply on any of those that you like the most. If you don't know which one, okay, then try ROS. Then try to program the robots. I think well, programming the robots is the final frontier for intelligent robots. The hardware is already there. It already exists, the hardware that allows a robot to clean a room completely. What it doesn't exist is the software that allows a robot to clean this room, for example. Well, you cannot see because it's behind the camera, but here is plenty of stuff in very different situations, except there, which is the pretty picture of the of the recording, but the rest is plenty of things. So you can, there is the hardware that can move around and grasp the things and so on, but there is not the software that can command a robot to clean this mess. It doesn't exist. This is just to tell to your audience that this is like the final point that we are missing. But this is in case that you don't know what to do, hardware, electronics, or software, maybe you want to try it on the software. If you are clear, then go for it. Go for it. We need the better hardware. We need better electronics also.
Right. So you're basically saying if you haven't decided yet in terms of whether you want to become a robotics mechanical or electrical engineer versus a robotics software engineer or ROS developer, then the future, the opportunity would be in the computer science and the algorithm and in the programming side of robotics.
In the others also there are many opportunities, because we need things more efficient, faster, and better in reactions times, less consumption, and less heat. So many other problems, many problems that are reducing the operability of the robot. Many challenges. So it's also, but if you don't know where to, let's say in Spanish, we say to put your egg, you know, there's this cock that wants to put an egg and doesn't know where. So then I would recommend you, hey, try to put it on the software side.
Cool, awesome. So Ricardo, you're the CEO and the founder of the Construct. Can you tell us a little more about?
Sorry, I lost your audio. It was muted.
Oh,
yeah,
okay.
Got it back.
It was an accident. Yeah. So my question was, you're the CEO and founder of the Construct. Can you tell us a little more about the Construct, what it is, and how my audience can benefit from your training platform?
Yes. So I learned ROS using the official documentation of ROS, which is very, very good. Well, it was very good at the time that it was released. It was like a wow, amazing documentation at that time for the standard. But even like that, it was difficult for me to learn, and it has been difficult for all the people that has started to learn ROS, because ROS is not simple. It has some concepts that are difficult to understand and to manage. Then because of that, then I thought about providing a better way of learning, a faster way of learning ROS. And it is based on a concept that is called constructivism. Constructionism, which is a concept developed by Seymour Papert. and he was a very good engineer also in the field of artificial intelligence. And he developed this concept about indicating that when you are learning the most is when you are practicing, not when you are hearing, but instead when you are building something, and then you can check very quickly if you are doing wrong, because you can see how the thing is breaking, is falling, is not reacting in the expected way. So you can rethink what you were trying to do and change it, and then see again and test it again. So this interaction with the system is what makes us learn faster. Then based on that, we created the construct, which is an academy that we don't use videos to teach. We don't use that. What we use is a text, is like a textbook, which is on the screen, but you have on the side, you have a simulation of a robot. It's a physical simulation. And it's a simulation that if you push it, then it will fall and it can break and it can crash and all that. So it's a physical simulation of a robot. So the text is teaching you how to program the robot. Then you had to program inside the academy. You had to program and run it and see the result of your program in real time. And everything of that is included on a web browser. So you don't need to install anything. Then by doing this, we achieve to teach ROS a lot faster. We actually have a program, it's called ROS in 5 days, that you can, if you follow this program, it uses different simulations with different robots. So you can see the concept in different ways, the same concept. And it has a project that you have to do it, and everything in an environment which is on the web that provides you all what you need. And especially this quick interaction with the robot to see if what you are doing is correct or not, because you are going to see the result on the robot.
Right. So it's a great tool because I know some of my audience, they cannot afford buying a robot, but they want to learn how to program a robot. Then your platform, your online training platform would be a great tool for them because it's very realistic. They can interact with the robot, they can program it, they can immediately see how the robot reacts to the program. And it would be very beneficial, especially for people who cannot afford buying a pretty expensive robot.
Yes, that's right. And also, let me say also that we recently have included, in December, we included a real robot lab. So even if the main lessons, they are done on the simulation for each student. So each student has his own simulations based on the unit, on the progress, and so on. But now we have included a remote robot lab. There on the other room that I have over there, then there is a lab with a Turtlebot 3 robot, which is available 24 hours, 7 days of the week. Then the students, they are requested to connect remotely from their homes to that robot and do some of the program. So they have to do, hey, you have to build this program, try on the simulation first. When this is running, then you put it on the real robot. And then you try also here on the real robot. And then you can see also an experiment with a real robot.
How cool is that? Yeah, that's super cool. Awesome. Thank you very much, Ricardo. We're running out of time, Ricardo.
Okay, yeah.
Thank
I
you
told you
very
that
much.
I talk a lot. I told you. I'm sorry.
I enjoyed talking to you, Ricardo.
My
It
pleasure.
was
My
great.
pleasure.
Yeah. So and then so we're planning to create a video, a roadmap video on how to learn ROS. So it'll be a collaboration between Ricardo and myself. So we'll hopefully sometime soon we'll create that video, which will give my audience and maybe your audience a clear direction on how to learn ROS, where to start, and what are the online resources, books, and even your resources to learn ROS.
Okay, perfect. It will be my pleasure also.
Sure. Thank you very much again, and we'll talk to you soon.
Thank you very much, Sina. See you.
Sure.